Hey everybody, it's Mr. Millington here. This video is all about 30, 16, 90 triangles. You just watched a video with Miss Rose where she talked about 45, 45, 90 triangles. The other very important type of special right triangles are called 30, 16, 90 triangles. You can probably guess what the angles are like in this kind, but let's go ahead and look at some examples and explore what happens with the sides of these triangles. Okay, so it says find the height of an equilateral triangle with sides of lengths 8. So go ahead and take a second and draw out an equilateral triangle. The sides of the triangle are all 8. They want us to find the height. Also, we sometimes call that the altitude of a triangle. It's if you drop the segment from the vertex straight down perpendicular to the opposite side. That's the height of the triangle. Anyway, so the sides are all 8. What happens when you drop this altitude straight down the middle of an equilateral triangle? First of all, that's a right angle there. What happens is it bisects this base down here. So this is 4, and now I'm trying to find this height. So I can call it h, or I'll just call it x. And that's what we're trying to find. And if you look at this, we have a right triangle here. And in this right triangle, I have 2 of the sides. I'm just missing one of the sides, which means I'm going to be able to use Pythagorean theorem. Before I do that, though, let's talk about the angles. We know that this one's 90. We know in an equilateral triangle that all of the angles are 60 degrees, because if you divide 180 into 3 equal angles, each one will be 60 degrees. So 180 degrees divided by 3 is 60. So these angles are all 60 in the corners. And then this one up here, it was 60, right? But if I drop that altitude, I split it right in half. So half of 60 leaves me with 30 degrees. So this is why we call this the 30, 60, 90 triangle. And again, it's a special triangle that has some cool relationships between the sides. So we've got the angles 30, 60, 90. Let's figure out what the height is here. Okay, so when I look at these 3 sides, the hypotenuse is the 8. So I'm going to do my Pythagorean theorem. I'm going to say x squared plus 4 squared equals 8 squared. X squared plus 16 equals 64. Subtract 16 from both sides. You get x squared equals 48. And then, of course, I want to square root both sides just to get x by itself. So you would get x equals the square root of 48. So if you check that in your calculator, it's not a perfect square. It is really close to 7. It's a little less than 7 because the square root of 49 would be 7. But let's see if we can simplify this radical. I'm going to make that list of those perfect squares that we use when we're simplifying radicals. I could have stopped already because these numbers are getting to be bigger than 48. But go ahead, see if you can find one that goes into 48. All right. Hopefully you found that 48 can be broken up into 16 times 3. And then the square root of 16 is 4. It gets to come out of the house because it's a nice perfect square. 3 is messy, so it's got to stay in the house. So 4 root 3 is the length of this, the height. 4 root 3. Okay, so we have 4 root 3, and then 8. You might see a relationship there, a pattern, but let's see if that holds up with some other ones. All right, so here's another 30, 60, 90 triangle. Again, you can imagine that this is like half of an equilateral triangle that got, kind of cut in the middle just by dropping the altitude right down the middle. If you kind of, just imagine the other side of it there. But let's say that this side is 5. All right, well, if that's true, then that means the hypotenuse would be 10 because, if this was a big equilateral triangle, right, all the sides would be 10. I would have cut that base in half when I dropped the altitude, which would have left me with 5. So let's go ahead and find the height. X squared plus 5 squared equals 10 squared. x squared plus 25 equals 100. Subtract 25 from both sides, you get x squared equals 75. You take the square root of both sides, you get x equals the square root of 75, which again, you look at these perfect squares, you might notice that 25 goes into that. So x equals square root of 25. 25 goes in 3 times, so it's 25 times 3. You can take the square root of 25, you get x equals 5. And then the 3 is messy, so it's got to stay in there. So it's x equals 5 root 3. So this is 5 root 3. Okay, so let's zoom out here and look at both of these at the same time. In the first problem we did, we ended up with 4 root 3, and 8. In this one, we ended up with 5 root 3, and 10. So hopefully you're seeing a pattern. Hopefully what you're seeing is, if you're not seeing a pattern, actually pause this, look at them for a second, and see if you can find it, and then unpause. All right, so hopefully you're back now after thinking about that. So what you might notice is that whatever this side is, right, the one across from the 30, the one that's across from the 60 is that same number times root 3, and then the hypotenuse across from the 90 over there is double whatever the shorter leg was. It's double whatever the one across from the 30 was. So we got the short leg, that's 5. We got the short leg, that's 5. We got the long leg, that's 5 root 3, and then the hypotenuse, that's 10. Here in this one, we got the short leg, that's 4, long leg, that's 4 root 3, hypotenuse, that's 8. All right, so let's summarize these this pattern. All right, so on this one here, I like to, just like Ms. Rose used in the other video, I like to use x to describe how the sides are related to each other. So the shortest side is always going to be the one across from the 30, right? The one across from the 30 is x. The one that's across from the 60, the longer leg, is going to be whatever that shorter leg was, but times root 3. And then whatever one is the hypotenuse across from the right angle, that one's double. So that one's 2x. So sometimes people write it like this. Sometimes people will write 30, 60, 90, and it's x root 3, and 2x. And that's our pattern there. Okay, so let's try out a few and see if you kind of can get the missing sides. So let's say on this first one that I give you that this is 19. Okay, well, think about the pattern and see if you can find what the other two sides are, and then unpause it and watch the solution. All right, hopefully you tried that and you're back. This side is 19, so I'm calling that x. That means the side over here across from the 60 would be whatever that is times root 3. So in this case, 19 root 3. And then the hypotenuse is always 2 times whatever the short leg over here is. So 2 times 19 will give me 38. Okay, let's try another one. I'm going to give you a different side this time. I'm going to give you the hypotenuse. I'm going to say that that's 26. So go ahead, pause it, see if you can figure out the other two sides based on the pattern. All right, hopefully you tried it and you're back. So here, this time I'm giving you the 2x side, right? So the side that's over here, the side that's across from the 30, right, that would just be x. So if 2x is 26, then x would be half of that, right? It would be 13. And then the side across from the 60 would always be whatever this side is times root 3. So in this case, 13 root 3. All right. Now there is one other case that can happen with these that gets a little tricky. What this case is if we give you the one that's across from the 60 and it doesn't have a radical on it. So for instance, if I gave you, I don't know, like 15, what you would have to do is do a little solving, or once you've done a few of these, you'll see that there's a kind of easy pattern that you can just pick up on. But again, I said the one that's across from the 30 is x. The one that's across from the 60 is x root 3. The one that's across from the 90 is 2x. So in this case, we're giving you the one across from the 60. We're telling you that it's 15. So what you can do is you can say, okay, well, 15 is equal to x root 3. And then we can try to solve this using some algebra. So if I want to get rid of a times root 3, I divide both sides by root 3. And you end up with x is equal to 15 divided by root 3. But then just like in the video that Miss Rose showed you, we don't like to have radicals on the denominators of these fractions, so we do something called rationalizing the denominator. So the way we do that is we multiply the top and the bottom. Got to do the top and the bottom times root 3. So when I do that, what I end up with is 15 root 3, and then on the bottom, root 3 times root 3 would be square root of 9. Square root of 9 is just 3. In other words, the square roots kind of cancel each other out, and you're just left with the number under there, which is, in this case, 3. So 15 root 3 divided by 3 is equal to 5 root 3. 5 root 3. 5 root 3. Okay. So we've got that 5 root 3, right? So that's what x equals, right? X equals 5 root 3. So that's this side over here, 5 root 3. And then that's 5 root 3. And then the side that's across from the hypotenuse is always double whatever that is. So if you double 5 root 3, you're going to end up with 10 root 3. All right, so anyways, that one, yeah, you definitely, probably want to practice that a little bit. But what you'll notice is like whatever this side is, if you divide that by 3, that's what the number here is. And then you have to multiply it by root 3. And then whatever this side is, you just double it to get that. So you'll see some practice of that on the homework. Definitely let Miss Rose and me know if you have any questions. And thanks for watching. Bye.